multiplied times the derivative of g of x, and then you add this to g of x times the derivative of f of x. Alright, we have our equation y equals 3x minus 2x squared times 5 plus 4x. First, you want to take the first equation and multiply it by the derivative of the second equation. And then you have 3x minus 2x squared times 4. Next, you want to take the second equation and multiply it by the derivative of the first equation. Then you need to add this to the previous part. So you have 3x minus 2x squared times 4 plus 5 plus 4x times 3 minus 4x. Lastly, you want to solve
the g of x times derivative of f of x minus f of x times the derivative of g of x all over gx squared. But g of x can't equal 0. Okay. For our example, we have y equals x minus 1 over 2x plus 3. Our top equation, x minus 1, is our f of x, and our bottom equation, 2x plus 3, is going to be g of x. Step 1, we're going to take g of x and multiply it by the derivative of f of x. So here's our g of x, and then here's our derivative of f of x. Step 2, we're going to subtract this by f of x times the derivative of g of x. So here's our first part from step 1, and then we have f of x times the derivative of g of x. Step 3, you're going to square g of x and then place it in the denominator. So here we have step 2, I'll figure it out, and in the denominator we have 2x plus 3 squared. Now we solve. So we distribute the 1 and the 2 into 2x plus 3 and then x minus 1. Then we come out with 2x plus 3 minus 2x minus 2 all over 2x plus 3 squared. We cancel out our 2 x's, and then we end up with y prime equals 5 over 2x plus 3 squared.
Alright, we have the power rule, and you have d over dx, x to the n, which is really just n to the x, n minus 1, and n is only real numbers. Alright, we have our problem, x to the 4th. First, you want to move the exponent to the front. Now you have 4x to the 4th. Next, you want to subtract 1 from the exponent. Now you have 4x third. Now we have d over dx to the x equals 1. And this means the derivative of a constant function is the constant.